In this example, we're looking at how to make a perfect square trinomial and then using that skill to help us solve quadratics using the completing the square method. And so the question says, what value of c will make a perfect square trinomial? Well, there are actually a couple steps to making something a perfect square trinomial. And it all stems from the fact that perfect square trinomials all have the form x squared, or the variable squared, plus 2 times the first term times the second term, usually x in this case, plus the second term squared. And so what we're really going to do is we're going to look at how we can take that and use that to our advantage. And so for the first one, we're going to have x squared plus 12x plus c, and we're trying to find the value of c that will make this a perfect square trinomial. And the way that you do that is to first take 1/2 of the b value, again remembering that this is ax squared plus bx plus c. Take 1/2 the b value and squaring it. And if I take 1/2 the b value and square it, so half of 12 is 6, and I square it, and I add that to the trinomial, that always gives me a perfect square trinomial. And if we check ourselves, what we'll get is 2 things that multiply to give you 6 that add to give you 12, and those 2 things are positive 36 and 2 things that multiply to give you positive 36 that add to give you positive 12 are x plus 6 times x plus 6. And if I were to multiply this out to check myself, I would see that I get a perfect square trinomial, and I end up back at x squared plus 12x plus 36. So this works every single time. So if I want to make a perfect square trinomial, what I'm going to do is I'm going to take the b value, I'm going to divide it by 2, or multiply it by 1/2, and then square it. So my b value in this case is -6, so I'm going to take 1/2 and multiply it by -6, and I'm going to square that answer. So 1/2 of -6 is -3. When I square that number, I get positive 9. And so x squared minus 6x plus 9, 2 things that multiply to give me positive 9 that add to give me -6 are going to be x minus 3 times x minus 3. This also works with odd numbers. If you notice, the first 2 b values were even. It also works with odd numbers, but we have to just remember exactly what you have to do when finding the c value of a perfect square trinomial. So we're still going to take 1/2 of the b value, and then we're going to square it. But this time we're going to get a fraction, because 1/2 times 5 is 5/2. And when I square 5/2, I'm going to get 25/4. And so if I have x squared plus 5x plus 25/4, I actually do get a perfect square trinomial. But this perfect square trinomial is x plus 5/2 and x plus 5/2. And you may say, how did you know that? Well, I can actually multiply this out and see that it works. So I have x times x, which gives me x squared. That's my first. I'm going to do my outers, which is positive 5/2x. I'm going to do my inners, positive 5/2x. I'm going to do my last, which is going to give me positive 25/4. Well, 5/2 plus 5/2 is 10/2. And since 10/2 is equal to 5, I end up back where I started. Also, another tip, if you look at what you get when you take half of the b value, that's always what you get when you factor. So what am I saying? I have 1/2 of 12, well that's 6, and it's a positive 12, so it's a positive 6, so I get x plus 6. I have 1/2 of -6 in my second example, so what do I get? X minus 3, because that's a minus 3. And I get 1/2 of 5, well what's that? 5/2, or 2.5, and what do I get? Since it's positive, x plus 5 over 2. Using that to our advantage, we now can use this step to make perfect square trinomials when we don't have them. And so those two steps are in how we use completing the square to solve a quadratic equation. So first we want to make sure our a term has the coefficient of 1. Then next we want to isolate the variable terms. We want to find half the b term and square it. We want to add the new term to both sides because it's an equation now and not just finding one value of c. And we want to factor what we have on the left or on the right, depending on where the expression is, and use the square root property to solve. So let's do that. So first, I always like to check to see if something is factorable. And so when I do that, I get 0 is equal to positive 13 plus 8x plus x squared. And then I recognize that there aren't any values of 13 that I can multiply to give me 8. And multiply to add that gives me 8. And so now I know that I can't factor this. It's also not a perfect square trinomial in its current form. So we make sure, because we're going to try to use the completing the square method, we're going to make sure that our a term has a coefficient of 1. We're going to isolate the variable terms. Now the variable terms in this case are positive 8x and positive x squared. So to isolate them, we need to move the constant term, or the c term, to the other side. And so we end up with positive x squared plus 8x, and I'm going to leave a space just because I know I'm going to put something there later, equals minus 13, or negative 13. Step 3 says find half the b term and square. So we're going to basically create a perfect square trinomial on the left, just like we just did, by taking 1/2 of the b term, and this b term is positive 8, and squaring it. And so 1/2 of 8 is 4, 4 squared is 16. And now step 4 says add the new term to both sides. Because this is an equation, I can't just add 16 to one side to make a perfect square trinomial. I'm going to add it to both sides. And so what I get is positive 16 on the left, and I'm going to add 16 on the right. So my next stage, after adding this new term, because this is our new term to both sides, we're going to end up with x squared plus 8x plus 16 equals 3. And my final step says factor, so I'm only going to factor the left. And I should end up with x plus 4 times x plus 4, which is x plus 4 squared, equals a number. And hopefully now you recognize that this is the same form that we had before of a isolated square term equals a constant. We're going to use the square root property to solve. So the isolated square term, when I take the square root of both sides, I get x plus 4 is equal to plus or minus the square root of 3. Now I'm going to end up with, now I have to isolate the x. So remembering that the square root of 3 and minus 4 are not like terms in their current form, so I have minus 4 plus or minus the square root of 3, and I end up with an irrational answer. I actually end up with two irrational answers. One of them is x equals minus 4 plus the square root of 3, and the other answer is minus 4 minus the square root of 3. So I end up with two distinct, unique answers that are irrational because I end up with the square root of 3. Just as finding the perfect square works with even and odd numbers, doing this also works with even and odd b values. And so we're going to use the same thing. We're going to recognize, hopefully, that even though it seems tempting, this is not factorable. There aren't two things that multiply to give you positive 8, but add to give you negative 7. And so we actually have to look for another way to solve this. So making sure our a term is 1, that's done. We're going to isolate our variables. So we did this. We're going to isolate our variable terms. So we get x squared minus 7x, and we're going to subtract 8 on both sides, leaving a space, equals minus 8. Okay? And then our next thing that we're going to do is we're going to take 1/2 the b term, right, and square it. So 1/2 minus 7 squared. So that's this one. And 1/2 minus 7 is -7/2. And when I square it, I'm going to get positive 49/4. So now I've done step 3. Now I'm going to add that to both sides. So I get x squared minus 7x plus 49/4 equals minus 8 plus 49/4. So now I've done step 4. Step 5 says factor and use square root property to solve. So when I factor what's on the left, if you remember the trick from before, whatever I want to factor on the left side, or not on the left side, on the side with the x squared, the perfect square trinomial, I get what I have when I divide the b term by 2. So I get x minus 7/2 squared on the left. And then on the right, I'm going to have to do a little bit of simplification. So I have minus 8 and I have positive 49/4. Well, I have a fraction. I actually have 2 fractions and I'm trying to add them together, which means I need a common denominator. And so in order to change my common denominator to 4, I have to multiply the top and the bottom of this fraction by 4. And so I end up with minus 32/4 plus 49/4. And by simplifying, I get x minus 7/2 squared equals, well, 49 minus 32 is going to be 17. So I get positive 17/4. And now I'm going to continue on with what I've done before. I'm going to take the square root of both sides, because that's my, after I factor, that's what I do, because that's the square root property to solve. And so when I take the square root of both sides, I get x minus 7/2 equals to plus or minus the square root of 17/4. In my next step, before I isolate the x, I'm going to try to simplify the other side. So I get plus or minus, remembering that you can split the square root over division. I get the square root of 17 over the square root of 4. Well, I know what the square root of 4 is. That's just 2. And so I don't have to rationalize my denominator because it's just a regular number of 2. It's not the square root of 2. And now I'm going to move everything away from the x value to isolate it. So I'm going to add 7/2 to both sides. And so what I end up with is x equals 7/2 plus or minus the square root of 17/2. And I could leave it like this, or I could put it together and get 7 plus or minus the square root of 17/2. And that's because they have the same denominator, and you're totally allowed to put together fractions that have a common denominator. And so this would be my final answer. I get 2 answers. One of them would be 7 plus the square root of 17 divided by 2. And the other one would be 7 minus the square root of 17 divided by 2. And those would be my 2 answers.